Dear students, in the previous class we have done some sensitivity analysis. We will continue with the sensitivity analysis in this class also. In this class we will discuss about what to do with the unused resources. Then the major portion of this lecture will be on explaining what are the limitations of our classical sensitivity analysis. That is what we are going to see in this lecture. Look at the problem that where we can reskill the employees. This problem we have discussed in the previous lectures. There are 3 bags the company is producing: standard bag, deluxe bag and lightweight bag. There are some resources utilized. So, when I run this one using solver, the objective function value is this much, and there you are getting some slack variable. What is a slack variable? Because all the constraints are less than or equal to type. See this, less than or equal to type. This is our slack variable. The slack variable, the slack value represents the unutilized resources. How we can make use of this unutilized resources? So, because of the slack of 91.6 hours in the cutting and dyeing department and 32 hours in sewing department, look at this this figure this well. The management might want to consider the possibility of utilizing these unused labor hours in the finishing and inspection and packaging department. So, there are some unused resources there. This can be resources can be reused here wherever there is a binding constraint is there. So, that is how we can reuse that. We have to reskill these employees, those who are working in cutting and dyeing and the sewing department, so that they can able to work in finishing department and inspection and packaging department. For example, some of the employees in the cutting and dyeing department could be used to perform certain operations in either the finishing department or the inspection and packaging department. In the future also, the management may want to explore the possibility of cross training the employees, so that unused capacity in one department could be shifted to other department. This is the meaning of reskilling employees. What is the reskilling? In certain department there are some unutilized resources there. So, that much resources that employees can be reskilled so that they can work in the other department. Now, I am going to explain what is this unutilized resources. This is the problem which I have taken. I am maximizing this. This is the problem I have taken. So, decision variables initially will put to 0, 0, 0. Coefficient of objective function I have written because I have taken these values from our problem where we are doing already this one. Then I have entered the constraint, then I have used the resources utilized, then I have written the objective function value. When I solve this, I go to data, solver. When you solve this, I need this answer, sensitivity analysis, limits. So, when I run this, so here in the answer, here I am getting this, yes, here I am getting slack values, that is 91.6 and 32. So, in these two department, this many hours is not utilized, that is the employees from this department they are kept idle. So, these employees can be retrained or reskilled so that they can work in the finishing department and inspection package department where we need extra resources. We will be studying how to reskill from one stage to another stage in detail in coming lectures, but at present you can understand that this slack resources can be reutilized by proper training. Students, we are going to see 3 limitations of our sensitivity analysis. One is simultaneous changes in the input data and changes in constraint coefficients and non-intuitive dual values. What is the simultaneous changes? Suppose z equal to 10s plus 9d. So, we have seen effect of coefficient of s, then we have seen what is the on our z value, and in our final value of s and d. Then similarly we have seen effect of d, coefficient of d on our z value, but we did not consider simultaneous changes. So, what will happen if there is a simultaneous changes, that we can see. Second one, changes in constrained coefficients. So, we have seen there are some value s, d something, say for example 5s, say 2d something. So, we did not consider if any changes in the constraint of equation, we did not see the effect of that. Then we will see what will happen, how to handle this. So, then non-intuitive dual values. What is the dual value? If the right hand side is increased by 1 unit, what is the changes on our z value? So, these things there will be a problem in interpreting these limitations, that we will see in detail. First we will see simultaneous changes in input data. The sensitivity analysis information in computer output assumes that only one coefficient changes. It is assumed that all other coefficients will remain as stated in the original problem. The range analysis for the objective function, that is range of optimality coefficients, and the constraint right hand side is only applicable for changes in single coefficient. We have seen there are 2 points. One is range of optimality, second one range of feasibility. So, whenever this range of optimality and feasibility, we are considering one value changes and its corresponding effect. If there are two values are changing, more than two values simultaneously, we cannot see the value which the result which we got with help of solver output cannot be interpreted. We have to resolve the whole problem. Now, we will see that is the case one. Second one, the second limitation was changes in constraint coefficient. Classical sensitivity analysis provides no information about changes resulting from a change in the coefficient of variable in a constraint. Suppose we are considering the adoption of a new technology that will allow us to more efficiently finish the standard bags. So, previously the coefficient of this one is finishing time. For finishing and finishing time it was 1s plus 2 upon 3d plus 1l less than or equal to 708. Assume that we have adopted a new technology due to which the time is decreased from 1 to half. This effect we cannot see on our sensitivity analysis problem. So, this has come due to technology. This technology is dedicated to standard bags and would increase the finishing time on a standard bag from its current value of 1 to half an hour. The technology would not impact the finishing time of deluxe or lightweight bags. The new technology which you have brought it, there will not be any impact on the D and L. So, the new finishing constraint under the new scenario is 1 by 2 S plus 2 by 3 D 1 L less than or equal to 708. We cannot interpret if any changes in the coefficient of constraint is happening, but we can see in the problem which we have discussed in the previous slides, we can see the cost of new technology. So, we adopted new technology, because of that the coefficient of S is reduced 1 to 1 by 2. Okay, we will see that how to make use of that change in the coefficient of the constraint. Even though this is a single change in a coefficient in the model, there is no way to tell from classical sensitivity analysis what impact the change in the coefficient of S will have on the solution. Instead, we must simply change the coefficient and rerun the model. Now, when we rerun the model, I have brought the output for both the model. What is both the model? When the finishing time was 1 hour, when the finishing time was 0.5. When it was 1 hour, you see the value of our objective function is this much, 8300. When the finishing time is reduced to half an hour, our objective function has increased. So, this difference, okay, we can interpret this difference can be considered as the cost of new technology. Otherwise, because of going for new technology, this we are getting this much gain in our objective function. So, what has happened? Note that the optimal number of standard bags has increased from 280 to 521. So, previously it is 280, now the standard bags, because the time it has, the new technology has helped you to do it at a lesser time, so that you are able to produce more number of standard bags. And the optimal number of lightweight bags decreased. You see that previously it was 428, now it is 331. So, this difference is the benefit of new technology. I will explain with the help of solver how we are getting these two objective functions, then what is the difference of these value of these two objective functions. Okay students, now I have taken the problem where the coefficient of S is 1. As usual I have formulated, when I solve this problem, so go to data, solver, as usual I have entered all the values. When I solve it, so see that objective function value 8300. So, I am copying this value. Now, what I am going to do? Now, I am going to change this coefficient to 0.5 instead of 1, because of new technology that has reduced the finishing time 1 to 0.5. So, I am taking 0.5. Again I am going to resolve it. So, go to data, solver, yes. So, this is, look at our new value for objective function. So, I am copied here. So, when I put here home, paste values. So, this is difference. This is when I am having new technology, the value of objective function this much. When I am having old technology is objective function this much. This is difference, $1171. This may be the cost of going for new technology. So, we are discussing about cost of new technology. I brought the, see this one, when we are having our value of this S, coefficient of S is 1, then when the coefficient of, now it becomes 0.5, this objective function value is increased this much. Here it remains optimal to produce no deluxe bags. Here this is S standard lightweight, S standard lightweight. So, we are not producing any deluxe bags because 0. Most importantly, with the new technology, the optimal profit increased from 8,299.8 to 9,471.32, an increase of $1,171.2. So, using this information, with the cost of new technology, will using this information with the cost of new technology will provide an estimate for management as to how long it will take to pay off the new technology based on the increase in profit. So, this increase in profit is just 1 year, maybe assume that this problem is solved for 1 year. Okay. Obviously, when you go for say assume that this is 1000. So, the cost of new technology is say 10,000. So, we can estimate approximately it will take 10 years to get back the cost of new technology. So, this value will give you a rough idea how much we are able to recover for the towards the cost of new technology. Now, the next limitation is non-intuitive dual values. Now, assume that the same problem, the management decides to add the requirement that the number of deluxe bags produced must be at least 30% of the number of standard bags produced. So, what is a new constraint? So, the number of deluxe bags that should be at least, so greater than or equal to 30% of your standard bag. So, what we can do, this is, now we have to add this new constraint, we have to add this new constraint, then we have to resolve the problem. So, what I am going to do, I am going to add this new constraint, again I go to resolve this problem. Now, I have introduced a new constraint, that constraint is here, this one. What is that? Minus 0.3s plus d greater than or equal to 0. Okay. So, when I am solve this, I am solving it, I am going to see the dual value. So, data solver, I have already have entered all the constraint. When I solve it, so I need this answer sensitivity analysis limits. Now, answer report is okay. I need a sensitivity analysis. When you look at the sensitivity analysis, this can be formatted. You click there, go to home, yes. Look at the dual value, okay, it is minus 1.38. So, I will interpret what is the meaning of this minus 1.38. Now, this is the dual value for the new constraint which we have added. So, the dual value of minus 1.38 indicates that 1 unit increase in the right hand side of the constraint will lower profit by $1.38 because it is a negative. What the dual value of minus 1.38 is really telling us is what will happen to the value of the optimal solution if the constraint is changed to 0.3s plus 1. That is what our classical definition of dual value. What is the definition of our dual value? If the right hand side of the constraint is increased by 1 unit, corresponding effect on our objective function, that is a dual value. So, this is our constraint. If you add plus 1 to the on right hand side, what will happen? Our dual value or objective function will decrease by minus 1.38. But there is no use of this interpretation. This is not required for us. Actually, what value will be useful for us is that we will discuss in the next slide. So, the interpretation of dual value of minus 1.38 is correctly stated as follows. If we are forced to produce 1 deluxe bags over and above the minimum of 30% requirement, the total profit will decrease by $1.38. Conversely, if we relax the minimum 30% requirement by 1 bag, that is D greater than 0.3s minus 1, so the total profit will increase by 1.38. So, if the right hand side is increased by 1 unit, so the profit will decrease by 1.38. If it is decreased by 1 unit, the profit will increase by 1.38. So, that is what this is meaning. If the D is greater than or equal to 0.3s plus 1, what will happen to our objective function? Instead of interpreting this way, we might instead be more interested in what happens when the requirement of 30% is increased to 31%. Here we are going for 1 more deluxe bags. Instead of this, see that we put limitation, it should be greater than 30%. Suppose it goes to 31% or it comes to say 29%. How our objective function will affect? So, this interpretation cannot be done with the help of our classical dual value. Only thing is what we can interpret, if 1 unit is added on the right hand side, then we can see what is the effect on our objective function. But if the value is increased from 0.3 to 0.31 or 0.30 to decreased to 0.30 to 0.29, that effect on objective function cannot be captured. That is why it is non-intuitive dual values. This cannot be done. So, what to do? We have to resolve the problem. Note that dual value does not tell us what will happen in this case. Also, because 0.30 is the coefficient of variable in a constraint rather than an objective function coefficient, just now we have discussed. If the coefficient of constraint is changed, you have to resolve it. Because there is no way to get this information directly from classical sensitivity analysis, to answer such questions we need to resolve the problem using 0.31, 0.32, 0.34 and so on. So, I have resolved it, I brought the final answer. When you look at this, it is started from 0, 20, 40, 60, 80, 30. Then suppose 20 to 21, what is the effect on our profit? That is what captured. So, when we look at our picture, so what was the problem? Our D is greater than or equal to 0.3s. So, 330 may be say approximately here, 30 may be here, 30 may be here. So, when you go for 0.31, so we have to change this value, again we have to resolve it, then we have to capture what is the profit, 0.32, 0.34 up to 100. So, this was our final result. There are two columns, in one column profit, in another column 0.3 to 100, that means 30% to 100% we have captured the corresponding objective function value. So, we will interpret this figure. Notice from the figure that the slope of the graph becomes steeper for values larger than 45. You see that when it is 45, the slope is becoming steeper. Hence, we see that the percentage less than or equal to 55% result in a modest loss of profit, because we got a negative, slope. More pronounced loss of profit result from percentage larger than 55. So, when your percentage requirement is increased beyond 55, we will be incurring more loss. So, what the management can understand from this figure? So, the management now knows that 30% is a reasonable requirement from a profit point of view, and that extending the requirement beyond 55% will lead to more significant loss of a profit. We have seen in the previous lecture also. If your objective function is greater than or equal to type, if it is binding, if you increase 1 unit on the right hand side, that means you are tightening the constraint, your expectation is increasing. Whenever your expectation is increasing, obviously what will happen, that the value of objective function will decrease. That is why we got the negative dual value. Another case, if the objective function is less than or equal to type, when you add 1 resources on the right hand side, that means you are relaxing your constraint. When you relax the constraint, the value of objective function will increase, so you will get a positive dual value. Here in this case, because the right hand side is greater than or equal to type, again you are increasing the right hand side value, that means you are very strict, that means your expectation is more. So, the value of D will become negative. That is the interpretation that manager can infer from this figure. Okay students, we have seen 3 limitations of our classical sensitivity analysis. Next we will take one problem. That problem will cover, or that problem will contain all type of constraints. What is the meaning of all type of constraint? There will be a equal to sign, there will be less than or equal to sign, there will be greater than or equal to sign. So, we will see that if there are all type of constraint is there, if you are able to interpret this problem, then any problem which we are going to formulate in future can be interpreted very easily. So, this is an hypothetical problem which is taken from Anderson, Sweeney, Williams as usual. The company, it is a semiconductor company, manufactures a portable radio system that can be used for two-way communications. The company's new product is suitable for use in variety of business and personal applications. The distribution channel for the new radio are as follows. Now, the company is thinking of different type of distribution channels, how to allocate our resources to different type of distribution channels. The company is considering 4 types. One is marine equipment distributor, business equipment distributor, a national chain of retail stores and direct email. Because of different distributions and promotional cost, the profitability of the product will vary with the distribution channel. In addition, the advertising cost and the personal sales effort required will vary with distribution channels. The table which is in the next slide summarizes the contribution to the profit, advertising cost and personal sales effort data pertaining to the problem. So, what is there? There are 4 distribution channel, profit per unit. So, the marine distributors, when you give the product to distribute via this distributors, you can get profit per unit is $90. Advertising cost, okay, for example direct mail need to be advertised more. Then personal sales effort per unit, this is under constraint 233. The firm set the advertising budget $5,000 and maximum of 1800 hours of sales force time is available for allocation to the sales effort. These are the 2 constraints. Management also decided to produce exactly 600 units for the current production period. Finally, the ongoing contract with the national chain of retail stores require that at least 150 units be distributed through this distribution channel. What problem the manager is facing now? The manager is faced with the problem of establishing a strategy that will provide for the distribution of the radios in such a way that the overall profitability of the new radio production will be maximized. That is, decision must be made as to how many units should be allocated to each of 4 distribution channels, as well as how to allocate the advertising budget and sales force effort to each of the 4 distribution channels. We have 4 distributions, how to allocate our product into the 4 distribution channels so that our profit is maximized by satisfying all our constraint. So, the problem which we have explained is formulated in a mathematical form. So, 90M, M represents marine, business, retail, direct mail. 90M 84, this we have taken from this value. Okay. So, advertising budget 10, this taken from this value, should be less than or equal to. Then sales force availability, this one is taken from this one. Then there is a production constraint. So, all the products should be equal to 600. There is another constraint, there should be greater than or equal to 150 retail stores requirement. Now, when you look at this problem, there is a less than or equal to type is there, equal to type is there, greater than or equal to type is there. Now, we will solve this problem with the help of Excel, we will interpret. Okay students, I have brought the problem here in Excel. As usual, I have entered it. So, this is decision variables, coefficient objective function. There are 4 types of distribution channel. This I have taken here, I written the objective function. Please look at the formula for objective function. Please look at the formula for resources utilized. Okay. Then the right hand side, then I have entered all the data into the solver also, data solver. When I solve it, I am getting this result. What is this result? For example, answer. See this, our objective function is $48,450. So, the value, final value, actually you have to align it. So, via marine distributor 25, business distributor 425, retail stores 150, though direct mail we are not doing this one. So, there is a sensitivity analysis report is there is a limits report is there, that I will explain now. So, the value of our objective function is $48,450. the value of our decision variable is like this: 25, 425, 150 and 0. Okay. Then when you look at the slack column, right, there is a slack is 0 because it is greater than or equal to type, so it is a binding constraint. So all the resources are fully utilized. And here also the slack is 0, it is less than or equal to type, all the resources are fully utilized. Now you see that the slack is 25, it is less than or equal to type, so it is a slack variable. This is unutilized resources, where the sales force availability resources is unutilized. Okay. So the last one is also slack variable. It is equal to type, we cannot say obviously it will be 0. We cannot say either slack or surplus because it is equal to type constraint. So how to interpret this Excel output? The advertising budget constraint has a slack of 0. Okay, here slack of 0, indicating that the entire budget of 5000 has been fully utilized. Okay, this has been fully utilized. The corresponding dual value of 3. So for advertising budget, look at this, dual value is this much. Tells us that if an additional dollar added to the advertising budget, okay, that will increase our objective function by $3. You see that this objective function is less than or equal to type, obviously in positive shadow price. So that will help to improve our objective function. So the company should, the possibility of increasing the advertising budget should be seriously considered by the firm. That is one interpretation. Another interpretation, the slack of 25. When you look at this one, that is sales availability, sales force availability resources. The slack of 25 hours of sales force availability constraint shows that the allocated 1800 hours of sales times are adequate to distribute the radios produced, and 25 hours of sales time will remain unused. Okay. This many hours the sales force will be idle. Because of the production level constraint is an equality constraint, look at this, there is equality constraint, this one, this constraint. The 0 slack variable, here there is a slack, the 0 slack variable, 0 slack or surplus shown on output is expected because we put equal to sign. We can interpret this Excel output in detail. The dual value of 60 associated with this constraint. What is this constraint? Dual value production level resources is a dual value. Shows that if the firm were to consider increasing the production level for the radios, the value of the objective function or profit would improve at the rate of $60 per radio produced. So because this is a positive shadow price. So the company is may think for increasing their production level. The surplus of 0 associated with this retail store distribution channel commitment is a result of this constraint being binding. So retail store distribution channel, this one. Why we are calling it surplus? Look at the constraint, this is greater than or equal to type. If it is greater than or equal to type, this instead of slack we should call it as surplus. And look at this, as usual I am saying, when you are tightening, if the right hand side is greater than or equal to type, when you again you are adding, you see that you are getting negative shadow price. So the negative dual value indicate that increasing the commitment 150 to 151 units will actually decrease the profit. This is the point I am emphasizing in the previous 2-3 minutes before also. Thus this company may want to consider reducing its commitment. If it is constraint is greater than or equal to type and binding constraint, we should not go for increasing. And you increase that, you are increasing commitment, that will deteriorate your objective function. What is our objective function? Is profit. So if it is a profit, your profit will decrease. Suppose the constraint is greater than or equal to type, the objective function is cost. So again you increasing on the right hand side will increase the cost. Okay, we should be very careful. So, this company consider reducing its commitment to the retail store distribution channel, because that will increase their profit. So, a decrease in commitment level actually will improve the profit at the rate of $17 per unit. In this lecture, we have discussed about how to reuse this unutilized resources, that is reskilling the employees. Then we have discussed about 3 limitations of our classical sensitivity analysis. At the end, we have taken a problem which has all type of constraint, less than or equal to, greater than or equal to, unequal to types. Then we have solved with the help of solver. Then we have interpreted Excel output. Thank you very much.